The standard form for writing down a polynomial is to put the terms with the highest degree first. Example, 3x2 minus 7 plus 4x3 plus x6. The highest degree is 6, so that goes first. Then the 3, and then the 2, and the constant last. The degree of the polynomial function is odd, and the leading coefficient is positive. The degree of the polynomial is 3, and there would be 3 zeros for the function. The function can be factored as x, and then x plus 1, and then x minus 3. So the zeros of the function are x equals -1, 0, and 3. And this would be the graph for that exact problem. Y equals x to the third minus 2x second minus 3x. Pascal's triangle. To build up the triangle, start with ones, and then continue placing numbers below the triangle in a pattern. Each number is to the two numbers above it added together, except for the edges, which are all 1. So 1 plus 3 is 4. 3 plus 3 is 6. 1 plus 2 is 3, and so on. So this is our original problem. Now from this 3 right here, we know that this is the third row. Third row, which is 1, 3, 3, 1. What we're going to do next is we're going to put the 1 here, and then 3, 3, 1. The next thing you want to do is take the 2m, and you're going to put it here. Now you're going to go backwards, so it's going to go 3, 2, 1, 0. So you're going to put that exponent with the 2m on each one. Next, what you want to do is take the n. So we're going to take n, and we're going to do the same thing, just backwards. So we're going to take it and go n, o, and then we're going to go n first power. We're going to go n second power, and then n to the third. Next, we're just going to put plus, 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 and that's it. Then we're just going to solve for this. So basically, we're just going to do this. 2 to the third power, we know, is 8. And 8 times 1 is still 8. Same thing. Anything to the 0th power is 1. So with that, we're just going to solve for each one of these. That will result in this answer. 8m to the third power plus 12m to second power and plus 6mn second power plus n to the third power. The greatest common factor among a set of terms is the largest factor that will divide evenly into each term. We look at these two terms. We see that they don't share a common variable, which means no variable can be factored out of these terms. We then look at the coefficients of the two terms and their factors, and we see if they share any common factors. Okay. The factors of 15 is 1, 3, 5, and 15. The factors of 3 is 1 and 3. In the two terms, they share the two common factors, those being 1 and 3. The largest of these factors is the greatest among the two terms, which means 3 is the greatest factor. When factoring out of 3 from both terms, we see that they do so evenly. To set up the problem, first set the denominator equal to 0 to find the number to put in the division box. Next, make sure the numerator is written in the descending order, and if any terms are missing, you must use a 0 to fill in the missing term. Finally, list off the coefficient in the division problem. Once the problem is set up correctly, bring the leading coefficient, the first number, straight down. Multiply the number in the division box with the number you brought down and put the result in the next column. Add the two numbers together and write the result in the next column. Multiply the number in the division box with the number you brought down and put the result in the next column. Add the two numbers together and write down the result in the bottom row. Then multiply the number in the division box and write the number you brought down and put the result in the next column. Add the two numbers together and get the result and put that in the bottom row. Next, all you have to do is write the final answer. And the final answer is made up of the numbers in the bottom row, with the last number being the remainder of the remainder must be written as a fraction. The variables of x starts off one power less than the original denominator and goes down with each term.